Start the recording. So, moving on into installation and configuration, we're going to make some assumptions, and one of them is probably not a good assumption that you have used Linux before in some capacity. And also, we're going to assume that you do know the basics of networking. If you don't know the basics of networking, you really should pick it up, especially if you're going to be in the cyber defense competition. And third, that you have an interest in security, otherwise it wouldn't be here. So why Linux? Well, nearly all of the useful security tools run in Linux, and most commercial security applications are also written in Linux. And Windows versions, in a lot of cases, lack the complete feature set, or often are one or more versions behind, if they exist at all. Good example of this is Snort. In Snort, you can't run what's called the shared object rules, which don't give you means you don't have good coverage for some of the more obscure vulnerabilities that are out there. One of the best things about Linux is that it and nearly all of its components are free. You can download this stuff without paying anybody anything and not violating any software rules. And just for purposes of this discussion, we're talking about Linux, but for those of you who may like BSD, Berkeley Unix better, you can use that as well. I'm going to say for all practical purposes, it's interchangeable with Linux. Couple pieces of trivia. Linux was invented in 1991 by a guy named Linus Torvalds, which is where the name Linux came from. And another interesting side fact on that is, I believe it was in 1999, in the Most Valuable Player, or in the All-Stars election, they signed up for voting for that for the first time electronically and put a website out there. And Linus Torvalds was selected as the #1 vote getter for center fielder. And it might have been some Chicago-style voting going on there. And also want to point out that there's two major common flavors of Linux that you'll see out there, Debian and Red Hat. We're going to be talking more on the Red Hat side and talking a little bit about CentOS. But everything that we're talking about does also work in Debian, which would include Ubuntu. Now, why do we pick CentOS? Well, it's easy, and it works. I've never had any trouble installing it. You can download it from the CentOS website, start up an ISO, and pretty much accept the defaults as you install. So what do you do once you mount the ISO and boot? You click Next a lot. You're going to select US keyboard, US English, Chicago time if you're in Chicago. You'll have to define a root password. Click Install to the hard drive. Unmount the ISO before you reboot, and then once you reboot, it'll take you to another script where you'll have to make up a non-root user. Now, here's some things that we think that you'll need, especially if you're going to compile code. And if you're going to use Unix properly, you will be compiling code. You'll need GCC and GCC+. That stands for the New Compiler Collection. And it includes not only the libraries you need for C and C++, but also includes some Fortran, Ada, Java, and many other supported libraries. I'm going to recommend they put in PCRE, which stands for Perl Compatible Regular Expressions, and PCRE Devel. That'll help you with a lot of open source projects, including Apache, PHP, KDE, Postfix, Analog, Nmap, and Snort. Steve, actually, my sidekick here, does not like Perl, but that's okay. If you don't like Perl, you don't have to use it either. There's actually, that's one other nice thing about Linux is that you don't have to use everything. You can use what you like. Flex and Bison Flex is a tool for generating scanners, programs which will recognize lexical patterns in text, and Bison is a general-purpose parser generator. It does a bunch of stuff I don't understand, but it's used in a lot of apps, so you will need to have it. And the last thing I threw on there was Vim. Vim is an enhanced VI editor, and we're going to talk a little bit about VI towards the end of the presentation. You do have to know VI if you want to use Linux efficiently, because VI is installed on every Linux system and every Unix system out there. It is a text editor that's very powerful. Some of the commands may seem a little bit difficult to get used to at first, but you only really need to know around 6 or 7 of them, and you can do everything you need to. So I'm going to turn this over to Steve, who's going to talk to you a little bit about Unix permissions.
So I'd first like to start off by saying permissions aren't hard. If you think permissions are hard, then let's go for a little bit of re-education here. So Unix permissions are basically broken down into three major sections. You have the user, the group, and everybody else. When you take a look at the way that user permissions are set up for any file in Unix, it's going to break down to those three different categories. And you can take a look at permissions in a couple different ways. The first way would be to simply call them as read, write, and execute, and then change those permissions based on however you want. So for example, what we see here on the screen based on permission, right? We see like U plus RW. So saying we want to add read and write permission to a given user. Another way to say would be all R minus RWX. So you want to remove, read, write, and execute from everything. There's another way to actually take a look at Unix permissions as well, and that's looking at the octal representation of how all that is set up. So for example, if you see, very commonly what you'll see is things like 755, 644, 600. If you use, some basic navigation tools like LS and you take a look at the listing, you're going to see all the permissions set up in this type of format. And to kind of break that down a bit, if we take a look here, here's a good representation of how that is actually broken down. If we take a look at 755, right, and then break that down, 7 would be the owner, 5 for a group, and 5 for others. And we break that down into RWX, 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 and then transfer that to octal. What we can see here is every number can only have a maximum of 8. And when you take a look at that, execute being 1, write being 2, and read being 4. So when you add all those numbers up, right, you're getting a good representation of what that is. 755, for example, would say that the owner has full permissions, read, write, and execute. The group has read and execute, and everybody else has read and execute. That would be great for things like directories. That would be great for executable applications. Another common one would be 644, where it's the same thing as 755, but we're just removing the execute bit and everything. The other thing to keep in mind, too, would be ownership. Ownership breaks down in two basic ways. We have the ability to change groups, so chgrp. At that point, all you're doing is specifying chgrp, specifying the group name, and then specifying the file or directory that you want to change that group to. Chown would be change ownership, and you can specify just the user or user and group that you want to change that to as well. To give you an idea of some examples, if we take a look here, where did you put that?
It's there. Just,
VirtualBox VM?
Yeah, it's here.
Oh, there we go. So showing a quick example of how all this is set up. If we take a look at an LS directory here, we're seeing things like this. We're seeing read, write, execute, read, write, execute, read, write, execute. This firedrill.pl script, for example, we see it's got the execute bit on all of them. If we wanted to change that permission, for example, what we can actually do is chmod. Then let's say we want to make that 644. Remove the executable bit on everything. Firedrill. And then if we take a look here, we see it's actually all that permission has been removed. And then we can go ahead and even re-add that as we go along as well. We also have the ability of changing the ownership as well. So we can say, maybe we want to make Firedrill have root permission. We can simply say, in this case, we want to make it with the root user and the root group. Oop. Helps if you can actually spell. Now, if we take a look here, that actually has root ownership. So I'll give you a couple examples of how you can actually, work with permissions and get that manageable. So if we take a look here and switch this back over, that leads on to you.
All right. I'm going to go over some networking basics. All this stuff is really easy, like pretty much everything else. I'm going to go over ifconfig, root, ethtool, and you guys can read the rest, I'm assuming. So ifconfig, mainly you use ifconfig to check what IP is set to an interface, whether an interface is up. And it'll also show you a lot of statistics about the interface. I apparently made that screenshot entirely too small since I can't even read it. But that shows you what it should look like on a CentOS box. To take an interface up and down, it would be ifconfig eth0 down or up. To set an IP address, you'd use ifconfig eth0 or whatever interface you want, and then basically all the options are there. To add a default route, which is definitely necessary when setting up a box, you'd use route add default gateway, whatever your default gateway was. And to display a current route, it's route-n. Removing a route is also extremely easy. It's as simple as route delete. Adding a route is as simple as route add. And if you want to look at more of these switches, you can look at the man page for route. I'm going to talk about ethtool a little bit. Ethtool is a tool that that can show what the speed duplex is on a specific interface. You can force auto negotiation on or off. I know in my line of work, sometimes we have to do negotiation off because client's equipment is sometimes retarded and likes setting things wrong. You can change the duplex quite easily. The -s basically is just a set bit, so it'd be ethtool -s eth0 duplex half full auto neg off. Same thing with the speed. So this is going to be the fun part: IP tables. So IP tables basically controls what comes in and out of a box. It controls all the packets that go to and come out of a box and how they're routed. The rules can be found in etc sysconfig IP tables. I wish I would have spell checked this before I went through. You can determine what rung levels you have enabled using check config. And you can stop and start it with service IP tables. To list out the rules that are in place already, it'd be IP tables -L. To specify a table -T. To insert a rule, it'd be IP tables -T, the table, whatever chain you're trying to put it in, and what the source or dest you're trying to match on, and what action you want to take. So what IP tables does is it splits packet handling into 3 different tables. Each table contains a number of chains, so I don't really have a board to write on since this is just a PowerPoint, but imagine chains inside of a table. Any rules that you create will be put inside a chain. And it's very similar to ACLs. It goes from the top down. There are 4 default tables: filter, NAT, mangle, and raw. Filter is obviously used for packet filtering. NAT is used for NAT and PAT capabilities as well as IP masquerading. Mangle is used to set different options on packets, and raw is used for exemptions when doing configurations. So we'll use filter as an example. Inside the filter table, there's going to be input, output, and forward. Some of the main targets that we'll use are accept, drop, and reject. The only real difference between drop and reject is drop just literally drops the packet. Reject sends an ICMP reply back to the client saying that it's been dropped. Oh, wow, these actually turned out really well. This is the packet flow through IP tables. So as you can see, it goes from the wire to the interface. It goes through raw pre-routing, connection tracking, mangle pre-routing, NAT pre-routing. It makes its routing decision where it wants to go. It goes through mangle forward, filter, forward, mangle, NAT post routing, and out onto the interface and out onto the wire. And this got apparently screwed up when it got transferred over, but I do have all these slides, or at least these tables, up on that URL listed in the bottom of this slide. This is more of this, but this one goes to the local machine. So it goes into the interface, through pre-routing, through more pre-routing through the mangle and that. It does the routing decision, and then it goes into the input chains. This is from the local machine going outbound, and so it goes raw output, connection tracking, mangle output, NAT output, does its routing decision, and then goes through post routing. So whenever you reboot a machine and you haven't saved anything that you've done in IP tables, yeah, it's all going to be lost. So you can do IP tables save and then save it to a file name, and similarly to restore it, it's IP tables restore and whatever file name you named it as. I'm not going to go into it, but you can do persistence editing by editing the rc.local file as well. Some helpful commands that I found: IP tables -l -vn -- line numbers. It'll display how many times the rule has been triggered, as well as line numbers for easy deletion. And this other one that I'm not going to read off because it's extremely long. It'll send all drop packets to syslog for easy sorting and documentation. This is especially useful during the CCDC.
Hint.
Yes, definitely a hint. So now I'm going to go into package management. So Red Hat uses RPM. There's several different types of front ends. That's Yum, UpToDate, Zyper, and mainly Red Hat, Fedora, CentOS. Things based off of Red Hat are going to use those. Debian uses apt, dpackage, synaptic, which I don't. Does Ubuntu still use synaptic?
Yeah, there's some synaptic package managers there.
All right. And these will use .deb files. So the essentials of RPM. RPM is the base program. You can query the what files are installed quite easily just using -QA. -QI will find out more information about a specific module that you have installed. QL will find what files a specific module has installed on your machine. And installing is quite easy. It's as simple as RPM-I for install. Verbose is V. H just shows the progress. So most of the time I use IVH. That's why I just went through that. It'll be a lot simpler and a lot less of a headache. And it'll show you where things went wrong if it doesn't install. So upgrading is UVH. Case matters for this, except PowerPoint decided to make it a capital U. Removing unwanted software is as simple as E for erase. It'll remove the software, and if you encounter any errors, you can kind of force it by using -E -- no deps. Or yeah, I do believe that's no deps, not no debs. For more, you're gonna have to read the man page. Yum is mainly what you'll use with CentOS. As it has GUI interfaces, but I'm not going to go over them because, quite frankly, I don't like using the GUI. And if you get into Linux, I would recommend not using them. Yum has very simplistic options such as install, update, list, and remove. They pretty much are self-explanatory. All right, so this is going to be regarding deb. So dpackage, apt, and synaptic. Apt is what you're going to use most of the time if you are using a system that uses deb. Honestly, I haven't used synaptic in quite a long time. So for dpackage, which is the base, again, very simplistic options. -I installs it, -L lists, and -R removes. For apt, it's going to get a little touchy. It's repo based. You can find what repos you have enabled in etc apt sources.list. apt get install will install. apt get update will resync with the repos you have, and apt get upgrade will upgrade packages to the newest versions. This upgrade will also do the same thing as apt get upgrade, but it'll also change the lower level stuff, so like the version of Linux that's actually running. apt cache show package will display more information about selected packages. apt cache search, and then a regex string, which you'll learn later on. So we'll search through the cache. Apt cache depends will show you what dependencies. And once again, if you need to know more, Google or man pages are your friend. You didn't remove this.
Was I supposed to?
Yes, since this is your section.
That's okay.
You want to come up here and do it then?
Actually, I think I hit the slide after that. I just didn't remove that one.
Nope, you definitely left the slide after that one.
Keep going.
All right. So for manual package management, generally you will compile it from source. The only one problem with compiling from source is there are generally a lot of dependencies. Some of them are documented, some of them aren't. So you kind of want to know what dependencies you need before you try and compile. Generally, if you do try and compile and you don't have all the dependencies, it'll just yell at you. And you can read through and see what you need. Some advantages are when you compile from source, they're a lot more tailored to your system and what packages you have installed. You'll sometimes get better performance, sometimes not, sometimes it'll be the same. Generally, they're smaller, don't take up quite as much room on your hard drive. You can edit the code before you compile it. I've seen some examples where people have edited SSH daemons and made it so that if you fail to log in, you have to wait for 7 seconds. It's very useful. And for some things that are in beta, it's sometimes just necessary to compile from source because they don't have binaries out yet. And this is yours.
Alrighty, so there's two basic tools when dealing with regex on Linux systems. The two that are going to be the most commonly used are going to be grep and sed. So the first one we're going to talk about here is grep. Grep is great for finding files, finding information about specific pieces, specific files, or finding specific information within a group of files. Right? It will display the matching line by default, and you can actually use regular expressions with -e or egrep. And to show you an example of that, if we take a look here, and we wait for Nick to type in the password again.
No, actually. No, 1, 2, 3, 4, 5.
So if we use an example here.
Continue.
Well then, if we use an example here and say, let's say we want to look for the IP address, right? So using a couple of the commands that we were using before. So we have this IP address here. Maybe we want to determine where this IP address is actually being set. Right, what we can actually use is grep and take advantage of some of the flags within grep. For example, we can use a -R, which will make it recursively look. And we can start looking for something like IP adder, and then where do we want it to go? So in this case, we're not necessarily using a regex string, but you can easily replace this with any type of regex available.
just a second.
Mhm.
Got a message saying that we're having trouble with video here. Okay, where? There it is. Okay.
Okay. So using that as an example, right, we were looking for the string IP80DR. What we can start to see here is we can see what files that this had actually occurred in, and the whole line that this had actually, that this was pertaining to. We could also use this individually and say maybe we only want to look at a single file. So if we take a look, for example, and we say maybe we want to look at the FS tab, and we want to see where, let's first cat FS tab. We got some data in here. Maybe we only want to see the line that actually pertains to swap, right? So in this case, we're just going to simply type in swap, FS tab, and we're only going to see that one line. And you can see where this can really come into play when you start talking about a large number of files, or if you don't know exactly where a given configuration option, maybe something like a default password is set into a set of scripts for web application. You can find this very easily to figure out where that line is. So if we switch back over here, the next thing that I wanted to talk about is actually set. Set is great for using for substitutions, and that's typically the most common use for it. It is a very, very powerful tool. There's a lot of options in there. I'm only going to be covering just the substitution piece. And so if we take a look here, we have two main ways of looking at that. Right? When you're running set, you can either look at it as, I want to replace the first instance, in this case using the bottommost line here, so S original string, replacement string, /. If we want to replace every occurrence, we're going to add the G to the end of that. So using an example here, if we take a look at this swap here, we can say, we're going to use set S swap off FS tab. What we're going to see now is the first instance of swap got replaced with swap off. If we want to then make that across globally, every time we see swap, we're going to add G. And now we can see where it can be replaced in multiple locations. And again, taking this into place of maybe default configurations in a web app or something like that, you need to change that default password very quickly. You can very easily do that with set by just replacing it and then redirecting that output back into the file. So if we take this, for example, and say we want to replace that globally, let's create a new file called fstab new. Now if we were to cat that new file, we can see in the file we now actually have all the new information. So some interesting ways you can start leveraging that. When it comes to actually dealing with regex itself, there's a lot of documentation on how to compile and write your own regex. And I think that's beyond the scope of this talk at this point. So I would highly recommend you start looking online, figuring out what regexes you're trying to do and how to do it.
And we're actually going to go back into compiling from source a little bit more. And one of the things I want to just talk about is that Google is always your friend. When you're looking for source and you're compiling, sometimes you'll forget things. You'll forget to have the right library installed. Sometimes it'll bark at you, and it'll say, "I am missing," say, libpcap. And if you don't know what libpcap is, you Google it, you find out what it is, where you can download it, how to install it. The bottom line here, the one that says configure, make install, you will use this a lot if you compile from source, because that is a great way of setting something up so it'll actually compile and actually show up in your, and I'll do it all in one step. So here is some source. This is from the snort.org webpage. If you go to download snort, you'll see the source stuff is up at the top there, then there's binaries below. Snort's actually pretty good about keeping up on binaries, and they generally have binaries out as soon as they have the code. There are some other applications where that's not always true. So that's why learning to compile from source is particularly helpful. But as Steve mentioned, sometimes the options you want are not necessarily there. Like you may have some certain there's often compile options that you can find in the executable or in the tarball. Usually in the README, it'll tell you what the options are. In source case, in the snort.conf, there's a recommended list of options they want you to compile with. So how do you start? Well, you start by untarring it, and so you should usually the command is tar, zxvf tarball.tar.gz or tar.xjbf tarball.bz2 if it's a bz2 file. It's pretty simple. Z means unzip, X means extract, V means verbose output, and F means archive, the file that is immediately following. So what's next? Configure, make, and make install. What does configure do? Well, this actually creates the make file, which is the going to be used then to build the program. And then the make install actually finds that target and installs it into the program. So sometimes things work when you do that, and then sometimes they don't. So here's a good example of what happens when something's gone wrong. You can see that there's in the code on the right, there's there's an error, kernel configuration is invalid. In this case, it's telling you to run make old config and make repair on kernel to fix it. So if I didn't know what that was, I would actually go out there, and in this case, actually, I didn't know what it was when this happened to me. I went out, I Googled it, found out what I needed to do. And I found some other people that ran into the same problem and managed to fix it and get it going. So here's the kind of thing you'll see when everything has worked. In this case, I was compiling a TCP replay. And basically, you can see at the end that all these things have executed nicely. There's no error messages, nothing glaring that says that things came to a grinding halt. So last but not least, I want to talk about VI. First, I want to emphasize that VI is not hard. It's very, very easy, and it's always present on every Unix or Linux system that's out there. And you'd really only need to know about a half dozen commands to use it. And here are those half dozen commands. I puts you into insert mode. This means you can start typing in text and have it show up in the line that you want to edit. Escape will let you leave insert mode. The slash outside of insert mode will let you find text. Very, very useful. And then when you're done and you've made all your edits, you want to write to the file. If you just hit, if you're in insert mode, you hit escape and then :W, and that'll write the file. And if you hit :Q, that'll quit the file. Sometimes if you have made some changes and you want to quit and it doesn't let you quit, you have to do a :Q with an exclamation point. That'll let you quit and discard your changes. Another one that I find particularly useful is the :N. That'll jump to a line number. That's really useful if you've gotten something like where it's a reading in a file and an application when you're trying to start it, and it says failed at such and such in this comp file at line N. Well, going to that line is very helpful at that point because then you can read and at least have a clue what might actually be wrong. So let's actually take a look at some of these and go back into, I'm just going to go edit a file. So let's VI the file that Steve created for me, which was really nice of him. So let's say I wanted to change some of the things in this file, and I wanted to, and let's pretend that the file is much, much longer, and I wanted to find swap off. All I would have to do is just hit / swap off, and it'll show me exactly where it is. And just as an aside too, if you want to find the next instance of swap off, if you hit N, it'll take you to the next one. And then if you hit past that, it said, you hit bottom, now you're returning back to the top. Let's say I want to start inserting text here, and I want to change this to swap off to swap on. There's a couple different ways you can do that. So if I hit I, now I'm in insert mode. Now I can just go and just do normal editing kind of things. And now, if I want to write the file, I would hit Escape W, and it wrote the file out to the file system. If I want to quit, I just do quit. Now let's say I'm going to actually use Vim now. Now Vim, if you remember, we installed that one. That one has some slightly different features in it. Oops. And if you don't give it a file name, it doesn't open anything special. So let's do temp fs tab again. Now you notice one of the things that's done here that's slightly different is you got colors now. Another cool thing with Vim is that it will actually highlight stuff for you when you search for it. So now if I search for swap, it's highlighted in kind of a nasty cold booger color. And definitely infected sinus stuff there. So again, if I want to hit the no, at this point you need antibiotics. So let's say I made some changes and I just typed in some random text here and I said, oh, crumb, I didn't want to do that and I've messed up too many things. I don't know where I want to stop and I want to quit this. So I can just go Escape Q, but it's not going to let me quit because I made changes and that doesn't want you to accidentally discard your changes. So I'm going to actually just hit colon Q with an exclamation point, and now I can quit it. And that actually is bringing us to the bottom of our presentation. And I'm going to check and see if there's any raised hands out there. There's no polls. And actually, you know what? I'm going to unmute people too if you... because you got a raised hand out there for Ethan Hobart. You're unmuted if you want to talk. Do you have a question? Okay, anybody else have any kind of a question out there? Then here's what we're going to do with this is that I apologize for in the initial part of the presentation. I think that the slides weren't being shown, but Lou is going to post the presentation out there, and he's actually going to post all the slides with it as well. So I'm going to turn it over to Lou then.
Okay, well, once I get this files from them, I'll post it up on the Illinois CCD website, so you'll have a link there to download the PDF version of the PowerPoint. And once we get this converted, we'll have this on YouTube. And we're going to be doing a series of events. If you go to the CASIA website and look under the Illinois CCD, there's a list of titles of what the next one's going to be, but we're going to do one every first Friday of each month between now and December. Be specific topics. We'll be doing the same thing on WebEx, and also if you want to come, if you're locally in the Marine Valley area, you're welcome to come up here in the M building and visit us and bring your machine. So all our events are going to be based on using CentOS. So if you wanted to follow along or anything like that, make sure you have CentOS running on your machine. Thanks.
And one last thing, I just want to look up the next one that we're going to be having is...
You go to the CASIA site.
That's where I'm at. I'm going to the CASIA site, training and events.
No, if you go into the event itself, it lists. It may not show, since it's already happened, since it's already started, it probably won't show anymore. But they'll be listed here by next week. We'll have the next one up there, so you'll see what it is, and then we'll post them on the Illinois website too, so there'll be a list on there next week for you.
Yeah, and actually this is going to be, there'll be on every first Friday of the month for the rest of the year. So we'll have the next month's topic posted shortly. So with that, we're going to say good night. Have a good Friday.
And if you have any comments, feel free to go to the Illinois CCD website and post your comments under the for this event. It's listed as the first topic for the thing. Thanks